The ocean keeps its secrets well. Far below the sunlit waves, where no light can reach, lies a place of profound silence and immense pressure. This is the Earth's final frontier, a world more alien than the surface of the moon. The deepest of all these secrets is hidden in the western Pacific Ocean, a long, dark crease in the planet's skin. We call it the Mariana Trench. It is the lowest point on the surface of our world, a place of perpetual night. It is a realm of crushing cold, of incredible quiet. And as we are now learning, it is filled with astonishing surprises. For generations, we have looked to the stars for wonder. But today, we will look down into the great abyss to uncover what is hiding 11 kilometers below. So, where exactly is this mysterious place? The Mariana Trench is located in the western Pacific Ocean, just to the east of the Mariana Islands from which it gets its name. These islands, including Guam, are a few thousand kilometers east of the Philippines. On a world map, the trench looks like a subtle crescent-shaped scar on the ocean floor. This scar is immense. It stretches more than 2,550 kilometers, over 5 times the length of the Grand Canyon. Yet it's surprisingly narrow, averaging about 69 kilometers across. Its shape comes from powerful geological forces. The trench marks a special boundary, a subduction zone. Here, 2 of Earth's tectonic plates meet. The immense Pacific Plate is slowly sliding beneath the smaller, younger Mariana Plate. Diagram. This process, one plate diving under another, is called subduction. To truly appreciate the challenge of exploring the Mariana Trench, we must first understand the pressure. At the surface of the ocean, we experience what is known as 1 atmosphere of pressure. For every 10 meters you descend into the water, the pressure increases by another atmosphere. Now imagine descending 11,000 meters. Down in Challenger Deep, the pressure is over 1,000 times greater than at the surface. This is equivalent to the weight of 50 jumbo jets pressing down on a single person. It is a force so immense that it can compress steel and crush most submarines as if they were made of paper. This is the first and greatest barrier to exploring the deep. This incredible pressure has a profound effect on everything. It changes the very chemistry of the water and the biology of any life that dares to exist there. For living organisms, this pressure would be instantly lethal. It would squeeze all the air from their lungs and crush their cells. The proteins and enzymes that make life possible in our world would be misshapen and rendered useless under such force. Any creature that lives in the trench must therefore have evolved unique adaptations to survive. Their bodies are not filled with air pockets like ours. They are often gelatinous and composed almost entirely of water. For most of human history, the deep ocean was a complete mystery, a place of myth and speculation. The idea of visiting the bottom of the Mariana Trench was pure science fiction. That changed on January 23, 1960. On that historic day, 2 men made the first ever crewed descent to the deepest point on Earth. US Navy Lieutenant Don Walsh, Swiss oceanographer Jacques Piccard. They climbed into a small spherical cabin attached to a massive submersible called the Trieste. The cabin was just 2.16 meters in diameter, with steel walls 12.7 centimeters thick. Their descent was slow, nearly 5 hours. When the Trieste finally touched the silty bottom of Challenger Deep, the 2 became the first humans to witness this hidden world. They peered through a small, thick plexiglass porthole, expecting a barren, lifeless desert. Instead, through the cloud of sediment, they saw something that changed our understanding of the deep sea. Piccard reported seeing a flatfish, something like a sole or a flounder, swimming away. When the first explorers peered into the trench, they might have expected a void, but, well, the reality is far more fascinating. The Mariana Trench is not a lifeless desert. It is a habitat for a variety of organisms that have adapted in extraordinary ways. The most common creatures found in the soft sediment of the seafloor are foraminifera. These are single-celled protists, like amoebas, that build protective shells around themselves. Unlike their relatives in shallower waters who build shells from calcium carbonate, many deep-sea foraminifera construct their shells from organic material. The intense pressure and cold water make calcium carbonate difficult to form and maintain. They are the humble, unsung survivors of the abyss. One of the most iconic residents is the Mariana snailfish, Pseudoliparis swirae. This small, translucent, tadpole-like fish holds the record for the deepest living fish ever discovered, thriving at depths of over 8,000 meters. It has a soft, gelatinous body with no scales, which helps it withstand the pressure. It also produces a special chemical called trimethylamine N-oxide, which stabilizes its proteins and allows them to function correctly under the crushing weight of the water column. Another group of important residents are the amphipods, surprisingly abundant in the trench. Some grow up to 30 centimeters. Deep-sea gigantism. These creatures are the cleanup crew of the deep, consuming detritus that drifts down from above. The exploration of the Mariana Trench has not only revealed strange and wonderful life, it has also uncovered some unsettling truths about our own impact on the planet. One of the most shocking discoveries came when scientists analyzed deep-sea creatures. They found animals contaminated with human-made chemicals. Pollutants such as polychlorinated biphenyls, banned decades ago, were concentrated in the fatty tissues of amphipods. Those chemicals sank into the deep and became concentrated in the food web, a chilling reminder that our actions reach the very deepest corners of the world. Even more tangible evidence showed up. Explorers found plastic. In a place no human had visited, our rubbish arrived first. Candy wrappers and other plastic debris. These items, discarded thousands of kilometers away, sank to the planet's lowest point. The discovery was a stark wake-up call. No part of our ocean is pristine. Beyond contamination, the trench revealed surprising geological activity. Scientists found methane gas seeps on the seafloor and evidence of hydrothermal vents, different from dramatic black smoke as elsewhere. These vents release heated, mineral-rich water and create small, localized ecosystems. Here, life relies not on falling marine snow, but on chemical energy from the Earth itself. Sampling trench rocks revealed microbial communities living deep inside the rock. Reaching the Mariana Trench requires technology that pushes the very limits of modern engineering. The primary tools are submersibles, human-occupied vehicles, remotely operated vehicles. HOVs are small submarines built to carry people. Trieste, Deep-Sea Challenger. Their most critical component is the crew sphere, a perfectly spherical chamber made of thick steel or titanium alloy. The spherical shape distributes the immense pressure, evenly preventing any single point from collapsing. HOVs have powerful lights and cameras to record what they see. But the workhorses are ROVs, unmanned robotic submarines. They are tethered by an armored fiber optic cable to transmit power, commands, and high-definition video. ROVs can stay down for days, meticulously surveying the seafloor. They carry robotic arms, temperature and chemical sensors, and high-resolution cameras. Another key technology is sonar mapping. Scientists map the terrain before sending submersibles. Multi-beam sonar sends fans of sound. Echo times generate detailed 3D maps of cliffs, valleys, and seamounts. This mapped Challenger deep with remarkable precision. Finally, landers free fall to the bottom, operate for days to months with traps, cameras, and sensors, then release ballast and float back with their data. These tools make the abyss observable. While we have discovered much about the Mariana Trench, one of its greatest mysteries is its role as a global engine. The subduction zone is not just a place where one plate slides under another. It is a massive conduit that connects the surface ocean with the deep Earth. Scientists believe the trench may swallow enormous amounts of water, pulling it down into the planet's mantle, along with the subducting Pacific plate. This could be key to the Earth's deep water cycle, influencing everything from volcanism to the long-term stability of our oceans. The central question is, how much water is going down, and what happens to it once it's there? This hidden water cycle is tied to another mystery, the carbon cycle. The trench acts as a giant carbon sink. Organic matter, marine snow, and the bodies of dead creatures carries carbon from the surface into the deep. Some is consumed and released, but a significant portion may be trapped and pulled into the mantle with the plate. This removes carbon for millions of years. We still don't fully understand the trench food web. What feeds the deepest ecosystems? Is it solely marine snow, or are chemical energy sources from vents and rock reactions more important? How do whale falls reshape communities for years? Perhaps the most profound mystery is the ultimate pressure limit of life. Our journey into the Mariana Trench ends where it began, with a sense of wonder and a deep respect for the unknown. This remote, dark, and silent world is not disconnected from us. It is a fundamental part of our planet's system, a hidden engine that regulates geology and regulates climate, a sanctuary for life forms that defy our imagination. The trench is a testament to the incredible resilience of life and the immense quiet power of our planet. What we have learned is that this abyss is not empty. It is full of secrets, full of life, and disturbingly, echoes of our world above. The discovery of plastics and pollutants in the deepest part of the ocean is a message. It tells us there is no away when we throw something away. It asks us to think more carefully about what we consume, what we discard, and to be better custodians of the one ocean that connects us all. The future of trench exploration is bright with new technology and discoveries. Better submersibles, more advanced sensors, long-term underwater observatories will let us stay longer and see more clearly. But we must explore with care and respect. This unique environment is fragile. It simply asks for our curiosity and our care, from the sunlit shores to its deepest, darkest heart.